Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most beneficent, the most gracious, the most merciful. This is Engineer Faisal Ijaz, and today I am presenting a lecture on the topic net positive suction head. Also, I want to introduce my YouTube channel of entitled Chemical Engineering Tech, and also I have presented different topics of chemical engineering, and in title of these topics are clearly visible on background pages. So you people will subscribe my channel, then you will get my latest videos. Today our topic is net positive suction head, so divert your attention towards this topic after watching these two pictures, and we will start our journey from a single word, which is head. So you can observe through this diagram easily what is head. So all the story of that topic run around a word head. So try to understand basic chemistry of that word. If you people explore that word, then you will find its conceptual name, which is power of the pump. If you people talk about head in a pumping system, so basically it will be the power of that pump. The pump head or discharge head of a water pump is the power of a pump. Here we are discussing about discharge head just to develop the concept of head. In the later pages we will go to suction head. So if the pump head will be greater, the pressure will be also greater. According to another definition of pump head, it is a maximum height that the pump can achieve pumping against gravity. So you people know well that if we want to work against gravity, we will use any external source, any external power. And if we want to drop a glass of water from a building at earth, we will not use a pump, as that work will be according to gravity. So always when we want to work against gravity, we will use a external force. Now you know well that head is height, and we measure that height according to length units, and we will use meter or feet to measure that head. During discussion of topic net positive suction head, we face a little problem, which is a confusion between pressure and head. So to resolve that confusion, we use diagrams to understand that chemistry. In this diagram you can see in a box water level is still 2.31 feet, and at the bottom of that box a pressure gauge is fitted, and which is showing us a pressure 1 psi against that height. In the second diagram you can observe that water level is decreasing till 1 feet, and against that height the pressure is 0.434 psi. So conclusion is that these both are different things, and always head create pressure, and as a result, if a pump produce more pressure, so higher head. After discussion about the word head, now you people know that what is head, and the head is height, also the power of pump. And now we proceed towards different types of head, and in this diagram you are watching different types of head, and first one is a suction head, the second one is discharge head, and the third one is total head. So the difference between these three types of heads indicating through their names also. And the suction head means height of fluid before entering into pump I. We will measure that height from top level of fluid source till pump I. Remember, we are just measuring height, not the length of fluid top till pump I. And if we are talking about discharge head, it's a mean head develop after pump action. So the bottom level will be eye of pump and the top level will be top of fluid level in container where we are receiving fluid through pump. So the total head will be the difference of height between suction top level and discharge top level height, and you can observe these definition according to this picture. If we conclude our discussion into an equation form, then it will be total static head equal to discharge head negative suction head, and the abbreviations are indicating HTS indicating total static head, HD indicating discharge head, HS indicating suction head. And now we proceed towards a fourth type of head, which is friction head, and the red line in diagram indicating that fourth head, which is starting from source till receiving container. So all the path from source to receive will produce friction, and all that friction is termed as a friction head. You people have concept about friction. According to definition, it is the resistance created by the different components of pumping system through which the liquid flows, and the main source of that friction will be inside roughness of pipe and different components used in pumping system. So after adding fourth head, the equation of total head will be like that: HT is equal to HD negative HS negative HF, and HF indicating friction head. Head is equal to energy, and before this topic we have discussed head is height, also head is power of pump, and now we discuss head is equal to energy. As you people know that head is height and is a vertical measurement from one level to another level. So the height between these two levels have a potential energy in static condition, but if we open the wall of that container, fluid will flow and energy will convert from potential energy to kinetic energy. So it's proved that head is equal to energy. So the conclusion is that head is really a form of energy. According to units, here we are using energy units, and the result is still feet, which is a height and also a head. After getting a lot of information about the word head, now we are running towards our main topic, which is net positive suction head. And before this, we want to know, why does a pump require a positive suction head? So it is impossible to design a centrifugal pump that exhibits absolutely no pressure drop. So pressure drop must be present at inlet of pump to start work, and that pressure drop will be the driving force behind the working of that pump. But all pump systems must maintain a positive suction head that is sufficient to overcome this pressure drop. If the pressure drop is not sufficient, some of the water will change state from liquid to vapor, and that will be the source of cavitation, and after that cavitation will be initiated. We are traveling towards our topic net positive suction head, as it's a topic of centrifugal pump, so it's important we have information about basics of centrifugal pump, as we will extract information for our topic net positive suction head. Till that stage, you people know that pressure drop in a centrifugal pump is a designing parameter, And to overcome this, we need head, also net positive suction head. Centrifugal pump has two purposes. The first one is receive the liquid, and the second one is deliver that liquid. And one misconception in that pump is that that pump suck the fluid, but now you people understand that it's due to pressure drop through which water join impellers. During development of net positive suction head concept, it's important to know about vortex formation, which is also a problem which create during pumping if net positive suction head will be insufficient. And you can see vortex picture, and during vortex air ingested into a pump body, and centrifugal pumps are not designed to pump compressed air, and centrifugal pump will drop performance quickly even with small amount of entrant air. So for a pump to operate cavitation free, and excess of pressure energy is required. We typically refer this requirement as a net positive suction head required and net positive suction head available. Net positive suction head required. At that stage, you people know that centrifugal pump face a problem which is cavitation, and you people have two terms, net positive suction head required and net positive suction head available. So if second term, net positive suction head available, will be less than net positive suction head required, then pump will face a cavitation problem, and the cause of that problem will be low suction pressure. So as a result, fluid will vaporize and bubbles will create, and after creation, bubble will collide to each other and create pressure. So after that pressure, cavitation will start. As net positive suction head available is a part of net positive suction head, so we will maintain that head or height to overcome this problem. Net positive suction head required is unique for each pump, and it's mean that for each pump the value of required head will be different, and that function will depend on geometric design and RPM of the pump. So the next is net positive suction head available, and in the diagram the circle is indicating pump, and both boxes are fluid sources, but the difference is that upper box location is above from pump, so it have positive head, and here head mean height from upper level of liquid till pump inlet. So if that height or head will be proper, then it will cover the pressure drop which create during designing of pump, and then cavitation will not be occur. The second box is below from the pump inlet, so it is negative head, and it is also called suction lift, as due to negative elevation refers to suction lift, like from a pond or a lower tank. If we want to find net positive suction head, then we will use that data, and here concentrate on that the final result is in feet, and it's mean it is a height and also a head, so head is also a height. So we will maintain only height if we are talking about net positive suction head. If that height will be proper, then no pressure drop and no cavitation will occur. according to summary of net positive suction head, NPSH stand for net positive suction head, and according to its definition, it is the measurement of amount of energy. And now you people know well that why he is using term energy, as we have discussed already that head is equal to energy, and after that energy will exert pressure on the fluid, and after pressure no cavitation will occur, no pressure drop will occur, so our pump will run in a smooth condition. And in these following terms, net mean a result of adding some positive and some negatives. Positive mean always positive, suction mean the inlet of the pump, and head mean energy in feet absolute. So hope you people will found some basic concepts of net positive suction head, and thanks to join us. Have a nice time always.